Hello viewers, let us look at this question. It says derive the equation. One fact you must know is that you can never derive the equation you don't understand. That is one solid fact you must know if you must penetrate physical chemistry. We must first understand what this equation is. These are rate constants, K2 and K1, for different temperatures, T2 and T1. So this is a mathematical relationship between the rate constants at different temperatures and the activation energy of the reaction. This is the molar gas constant. Now, to derive this equation, we must remember that this equation resembles an equation called Arrhenius equation. Arrhenius equation states that equilibrium constant of a reaction equals the frequency factor A times the base of natural logarithm E raised to power minus activation energy of the reaction divided by molar gas constant times absolute temperature. We are going to call it equation 1 because from this Arrhenius equation we derive this equation. We must note that there are two different temperatures. So you say at two different temperatures. Equation 1, which is this Arrhenius equation, is split into two because two different temperatures are involved. To do that, we must write this equation in terms of first temperature T1 and also in terms of second temperature T2. So to do that, we will create K1 and K2. K1 is A E raised to power minus EA over RT, and we call it equation 2. And K2 equals A E raised to power minus EA over RT. Remember, this T is T1 and this T is T2, and we call it equation 3. The next is to find the ratio of K2 and K1 because equilibrium constant K is the ratio of K2 to K1. K2 divided by K1 equals the whole of this, which is a K2, divided by the whole of this, which is a K1. And we have this. We call this equation 4. The frequency factor up there and down there are going to cancel each other. K2 over K1 equals E raised to power minus EA over RT2 divided by E raised to power minus EA over RT1. We call this equation 5. According to law of indices, this is the same base. And then what happens to the powers? Because of this division, the powers will subtract, right? This power will subtract this power. And we have minus EA over RT2 minus this power. Unfortunately, this power has a negative charge. So we have minus minus. And minus minus is plus, right? And we have this. Now look at this. EA here is positive. The whole of this is positive. And the whole of this is negative. So it's better we bring this here and bring this there. When we do that, we now have T1 here and T2 here and negative here. And after this, you take natural log of both sides. Because if you look at this, it is gradually resembling this. And natural log of both sides means ln or log in base E. But let us take log in base E. So log in base E of K2 over K1 equals log in base E of E raised to power EA over RT1 minus EA over RT2. Now finally, according to power law in logarithm, the power will go and multiply the logarithm. And this logarithm is log of its own base. So log E base E is 1. Now take your screenshots. Let's continue from here. So we have log in base E times K2 over K1 equals, now this power comes here and we have EA over RT1 minus EA over RT2 times log E base E, which is 1. Log in base E is the same thing as ln. So we have ln K2 over K1 equals, now look at this, we can simplify this by taking what is common here. And you see that EA over R is here, and EA over R is also here. So we say EA over R times, when EA over R divides EA over RT1, this we cancel and we have 1 over T1 minus EA over R divides EA over RT2, we have 1 over T2. And this is the required equation. Quad erat demonstrandum. If you found this video useful, click on the share button, share it as wide as possible, and make sure you are a subscriber. Bye.